Okay, today we are doing right triangle trigonometry and we are solving for unknown sides. So we're going to start by reviewing a triangle. So in a triangle, the longest side is always called the hypotenuse. Okay, and then this is one leg of the triangle and this is the other leg of the triangle. Okay, now we're also going to revisit Sohcahtoa. So a lot of you learned that in Math 2H, and what the S stands for is if you want to know the sine of an angle, you take the opposite over the hypotenuse. So in this particular problem, because this is the angle, even though a triangle has 1, 2, 3 angles, because this is the angle theta, and that's what we're asking, this is the side opposite theta. And then this right here, this side is the side adjacent. So it touches the adjacent side. It does not touch the opposite side. And then again, the longest side is the hypotenuse. So when you want to find the sine of an angle, it's opposite over hypotenuse. So like Chief Sohcahtoa, S-O-H, so. And then the next one is cosine, and that's adjacent over hypotenuse. So that's the ca part, C-A over H. So if I want to know the cosine of this angle right here, I just take this leg and put it over that leg. And then the last one is tangent, and that's opposite over adjacent. So that's going to be opposite over adjacent. Okay, and that's the TOA part. We also learned when I was in high school, some old horse caught another horse taking oats away, and then there was some old hippie caught another hippie tripping on acid. There's all kinds of interesting ways to remember that. Now you might be wondering what these guys are right here. These are called the reciprocal functions, or as I like to call them, refliprical. And the reason why is because, look, sine and cosecant are reciprocals. You just flip your fraction. So you might be asked a question like over here, which says the cosecant of theta, and you're like, oh my goodness, I don't remember cosecant. Who does it go with? Who's its reciprocal? Well, we go to Steele Canyon High School. Well, maybe you do, but we're from Steele Canyon High School. So if you notice, between sine and cosecant, there's one that's an S and one that's a C, like Steele Canyon. And then if you go to cosine, there's secant, which starts with an S, and its reciprocal is cosine. So people have a tendency to put cosine and cosecant as reciprocals, but that would be two C's and not an S and a C, so you always need one S and a C. Now that pattern doesn't work for tangent and cotangent, but I think you can figure that one out on your own. Okay, so let's get into the first example. We have a triangle here, and the angle that we're referencing is theta. So say theta. This is how you pronounce this guy right here. That's a Greek letter theta. So we are looking for the sine of theta. So sine, you're going to have to remember this. Sine starts with an S, Sohcahtoa, so this is opposite over hypotenuse. Okay, so that's opposite over hypotenuse. So when you make your triangle, with respect to this angle right here, not with respect to the other angles, but with respect to theta, that's the opposite side, this is the adjacent side, and this is the hypotenuse. The hypotenuse is easy because it's always the longest side. So opposite is 8, hypotenuse is 10. So if you don't see that you can reduce that, then into your calculator, you need to do that. So you have 8 divided by 10, which gives you 0.8, and then you go math, enter, enter, and you'll see it's 4/5. So that's 4 over 5. Now it's really easy to go ahead and do the reciprocal right away because you just flip it. So that's 5 over 4. Next one is cosine of theta. Cosine, Chief Sohcahtoa is telling us Sohca, so that's that right there. And then adjacent to theta is 6. and the hypotenuse is 10, and when we reduce that, we get 3 over 5. Sweet. So then the reciprocal, cosine and secant are reciprocals, that's 5 over 3. The last one is tangent, which is opposite over adjacent. And for that one, you're going to do opposite, which is 8, over adjacent, which is 6. So then when we reduce that, we get 4 over 3. So then the reciprocal of cotangent, the reciprocal of tangent is cotangent, and it's going to have a value of 3/4. Alrighty? So I just wanted to point out, if you did h over a, or h over o here, then you would get h, which is 10, over o, which is 8, which reduces to 5 over 4. So you can do the math for those two if you want as well. But if you're already doing the math for these, then it's just easier to just flip your answer that you got for them, because that's the whole point. Like, math is full of patterns, and those are the reciprocals.